So, as I said, this is one of the few times when we pass around cryptic information. It's a good thing that the developer doesn't have to deal with those numbers directly. Developer doesn't actually have to deal with claims directly at all. Claims are part of the identity of the person. Okay. The identity of a person is encapsulated in a class. A very, very unusual class. Unusual in that it is a static class. Static classes are extremely unusual for us. I could probably count on one hand the number of static classes we have in the code base. This particular class is static because I wanted it to be available no matter where you are in a service. And that is almost never true of any other code that we have. So the security utility holds a structure called the HSP claims identity. The HSP claims identity has a set of methods on it that allows us to query the claims very easily. So we have built a Fluent interface on top of that HSP claims identity structure. The Fluent interface, I don't know if anybody's ever studied that, but it allows us to string together commands. In this example, we have security utility.hsp claims utility dot has any permission within, and then we give it a security enum. So what the developer is saying here, does this person have any permission within payroll data? Now, what we mean by in is payroll. Our permission action is actually a tree where a permission could have children, and children could have children ad infinitum. So in this case, what we're saying is, if this person has any permission whatsoever under the parent of payroll, then this statement, dot has any permission, would return true, or would return a value. And then we go on. Remember, it's Fluent, so we string these commands together. For company. So it's going to check now. I want to know that if there is any permission under the heading of payroll for a particular company ID and entity. So not only will they have to have a permission for a payroll permission for company, number 28, but they would also have to have a permission for, say, company entity 42 or whatever it may be. Quick word about company and company entity again is that our clients have satellite offices across the globe. So one company, let's say there's a company called Acme. Acme could have an office in Australia and one in India and one in the UK and one in the US, etc. So Acme might be company 23, and Brazil, for example, might be company entity 32. So what this statement is saying is, does this person that is currently authenticated, who has made a call to this service, have any permission within payroll for Company 23, Acme, and Company Entity 42, Brazil. And that's all we have to do. The HSP claims identity will then be tasked with the job of looking at the claims, looking at that data in the claims, and determining if the person has permission or not. So the developer is abstracted away from all of that dirty business of cryptic information. I'll pause there for a second and give people a chance to ask a question if there is one.
Sure. John, there was one question.
Sure.
When we say like in Chrome we are setting certain values. Now these values are used here. So does that mean that like an user may have access to payroll of one, particular branch, multiple branches?
Yes, that's a very key concept of um, radius in general. Is that permissions? Let me get a notepad here. So let's continue with our let's talk about some nomenclature first. So we have the concept of a company. Descending from company is customer. Also descending from company, oops. Also descending from company is the notion of an LSP. An LSP was the old word. It's been changed now in business. LSP equals um, local service provider. That's what we used to call them. Now we call them an affiliate. What's an affiliate? An affiliate is a company that we use to do some service for us. Here's an example. We could have a customer that has an office in, say, Kenya. Well, we don't have any expertise in the company, any accounting, or I think it's termed bookkeeping in India. We don't have any bookkeeping expertise in the company that knows local Kenyan rules, laws, tax laws, whatever it may be. So we will hire a company that's local to Kenya that knows everything they need to know to service our customers. That's an LSP. That's an affiliate. Okay. This is a good opportunity to tell you that a business term may or may not be uh, a term that we use in code. For example, they are now called clients, not customers. Well, when we started, it was called customers. So all over the code is our customers, and we're not going to change that just because business has changed their terminology. So a company can be an LSP or a customer. Now, a company has a one-to-many relationship with a company entity. So for the developers out there, it can be said that company has a one-to-many with company entity. Great. Let's look at company entity now. A company entity so we have the notion of an LSP entity and a customer entity. These descend from company entity. An LSP okay, I'm not going to go into that level. So now back to Haman's question was that our platform, our code, our software, our offerings work on the notion of multi-tenant. So it's probably a word that you're familiar with. I'll just take 10 seconds to discuss that for a moment. Multi-tenant means that our software has many tenants, but each tenant is separated such that they think they are on their own website. So imagine this. We have hundreds and hundreds of customers. Can you imagine if we made a website for each customer and a database for each customer? We would not scale very well. So of course we didn't do that. Instead, we built a multi-tenant application, a multi-tenant platform. Let me see if somebody is Skyping me. Sorry. And training session. Sorry. Okay. Sorry about that little disruption there. Let me get back to where I was. Okay. So we have a multi-tenant uh, application. Now, here's the important part, is that one user could have access to one or more companies. What kind of user would have access to one or more companies? Well, only a Radius user. A customer user would never have access to any company other than their own. Within that, a user could have access to the headquarters. There's that word again, headquarters. What is headquarters? Headquarters is the main office. Where is the main office? The main office, yes? Hello? Somebody just asked Haman, you just asked a question?
I didn't hear you for long periods.
Oh, okay. Um, well, let me back up. Where did you hear me here talk about this?
Yes, yes, yes.
Okay. So one user could have access to one or more companies. A user could have access to headquarters. Headquarters is not a company entity. Headquarters is where the company lives. Okay. A user could have access to, let's say, company entity. Well, at this point, let's call it customer entity because they're different. To customer entity Brazil, but not UK. A user could have access to payroll, but not expense reporting. Now, a user could have access to approve payroll, but not fund payroll. I hope you can start to see how big this matrix could get. One user, one Radius user, could be servicing 40 different companies. And those 40 companies could have, 5 and 6 company entities. And they could have purchased payroll and expense and HR and on and on and on they go. And each application has many different levels of what you could lock down. Payroll, approve, or fund, or define, or any one of a number of privileges. So I hope how now you can see the number of claims just growing and growing and growing. And that's why it was important that one, we put the claims in a distributed cache because there's no way I want you to go back to the database every time. And two, that the claim was cryptic so that we can compact the information so that data structure would be as small as possible. It is one of the few examples of optimization that we have in the entire platform. Optimization is far different than efficient code. It means a different thing than performance, and certainly than scale. We try to stay away from optimization because optimization costs money. And you could be optimizing things that you shouldn't be. For example, think about this. If I have a piece of code and that piece of code has to do something, and that piece of code takes 400 milliseconds to execute, or let's say it takes 1,000 milliseconds to execute. That's a very long time in a computer. But that doesn't necessarily mean that that's a long time for that task to execute. In fact, it could be a very short period of time. And the answer is it depends. Depends what we're trying to do. If we have this thing in a loop and we're calling it a million times, then obviously that's a problem. So I'm not going to go optimizing a call, even though it takes 1,000 milliseconds. I'm not going to optimize that thing if I have to write special code to do it, because it's fast enough. Now, there is a big difference, in case you're not familiar, between these words and this word. Performance and scale are two terribly different concepts that some developers mix up. Performance is how fast can a particular code return, how fast can a particular piece of code execute, return a value. So in other words, if I'm a user and I say, show me an invoice, and that returns in 1 second versus 100 seconds. Well, the 1 second performs better than the 100 seconds. That's performance. Scale is more like this. We have 1,000 users that ask, show me an invoice. How long does it take? If it takes 1 second, or maybe 1 second log n, two log n, then that's pretty fast. That's pretty good. That's pretty scalable. If it takes 1,000 seconds because I have 1,000 users and it took 1 second here, 1,000 here, that's not scalable. Right? That's very bad. Yet it still performs very quickly. So performance and scale are two very different things. Okay, enough about that. I'm getting off on tangents. So hopefully that started to address your question, Hemant. And any follow up there?
Completely.
I'm sorry, once again.
Yeah, I got the answer to an extent, but I still have few more. Probably like I'll ask you later.
Okay, that's up to you. I mean, if you have the question in your mind, then maybe others do too. If you want to ask me later, I'll leave it up to you. Okay. All right. So back to what I was talking about back here. So that's what a security call might look like. Okay. So this is starting to get into the part where I was talking about it's going to get a bit more technical and maybe not as applicable to QA or configuration management. So by this time, maybe you have seen frameworks. This is not a session about frameworks, but it's just a quick introduction, a quick summary. Frameworks is a DSL, a domain-specific language. It is the focus of our development efforts. It is what writes 56% of the code at last count of our code base. And more than that, it allows us to visually view what a service looks like. So since I was on the security train, I'm just going to show you what frameworks does when a WCF or other type of operation is called. So let's take the operation get payroll definition list. So I first want to say that, 1 second, let me find it. Sorry. One moment, please. Okay, I can't find it at the moment. It is a property. There's there's a concept called a claims enabled service. And a claims enabled service means that,
John,
yes,
yeah, so click on the operation. Click on any one particular operation. Get payroll period.
uh-huh.
Okay, not there.
No, it's part of the service
I think
it's part of the service
it should be.
configuration.
No, I remember seeing it. Okay, you go ahead.
Yeah.
I remember seeing it. Yeah.
So anyways, it's called a claims enabled service. And a claims enabled service is a protected service. Most of our managers that talk to our websites, if not all of them, are claims enabled. So claims enabled means that you can't even get into the service to run an operation unless you have that security token that we spoke of yesterday. If you have the security token, you're allowed to get inside the service. And then it's up to the operation to determine if you have enough privileges to call that particular operation. So what I want to do right now is I want to kind of go down that path of looking at how the service or the operation determines what's going on. Now, one of the artifacts that frameworks creates is sorry. One of the artifacts that frameworks creates is the service, the WCF service class. So those of you who are familiar with WCF, some of this might look familiar. Here's a service behavior attribute, and this is the class that WCF will instantiate on an operation. Now this is generated. I want to say this. Generated code looks very different than our handwritten code. It's not as pretty to look at because it's generated, you know. It still follows pretty good single responsibility and solid principles, but it does look a bit different. There are comments in generated code. You will almost never see comments in our code. Almost never. Think about that for a moment. I really don't want people commenting code. Now, you might be thinking, John, what are you talking about? Comments are good. And for this, I will go back to something Mark Twain said. Mark Twain said, it is not what you don't know that will kill you. It is what you think to be true, but ain't. It's a very profound statement, and I more or less live by that statement, believe it or not. So here's why I don't like comments. Comments are good at the time, or not so good, at the time that you write it. Your code changes and the comments go stale. Comments take time to write. You don't need comments. I don't want you to write comments. Our code is self-documented. It is. And it's self-documented because we follow solid principles. The names of the methods and the names of the classes are the comments. You don't need any other commenting. You will see very little green in our code base. There are extreme situations where I need to explain a concept. Most of the comments in the code base, believe it or not, are mine because I'm doing something extraordinarily complex. And I'm not commenting the code, I'm commenting the concept. And the concept won't change, but the code will. Okay. But code-generated comments, that's a little different. And the reason why comments in code-generated code does not change is because if we change the code generator, then we can change the comments. So it's a terribly different story. Okay, so let's get down to where I was talking about. Let's get down to, this is code generated now. And let's look at this operation. So this particular operation gets the payroll definition list. So let's see what the code generator does. It starts off by creating a new data contract called get payroll definition list response. If we look at the model, we notice that there is a get payroll period list request and a get payroll period list response. So the generator starts off by creating a new get payroll definition list response object. It then will resolve using our IOC manager. It will resolve a class called the get payroll period definition list operation. The operation class is the thing that coordinates the code for the operation. It will get an object cache. I'm not going to get into that now. Pass the object cache to the operation. Pass the object cache to the authorization object. And then it will call the authorization object. And this is what I want to talk about. The authorization object, or the get payroll definition list authorization, is nothing more than a class. What does that class do? Well, we've already seen it. That class will tell us if this user can get into this operation. So it will run can get payroll definition list, and here's where the developer writes a little hand code. This is not generated because we really don't know what the developer wants to do here. So the developer writes this line of code and returns the Boolean. Then, where was I? I was on the payroll period manager here. Then, if it is authorized, we move on, and if it is not authorized, we throw an authorization exception. So now think about this for a moment. A claims-enabled service will always create an authorization object for every operation. The authorization object will have a method that will return false. So if you don't write any code there, then it's going to return false and nobody will ever get into the operation. And it was done like that such that the developer can't forget to do it. Because if they forget to do it, everybody will always be false. And that's how we protect against, just bad code or code that we forgot to write authorization. And you can't get around that because this operation is managed by generated code. So the developer doesn't have to worry about any of this, just has to worry about let me write my operation telling the system whether or not it can access that whether or not the user can access that operation. Once it can, then it moves on into the operation class, and at that point, get payroll period definition list operation, this class doesn't have to worry. This is the operation itself. This class doesn't have to worry at all about authorization. Remember the single responsibility principle. The operation should never be responsible for authorization. It doesn't have anything to do with it. Nothing. Zero. By the time we get into this operation, the only thing that this operation has to consider is how to fill the request. Really important point. And I think that's all I'm going to say about authorization and security. But let me open up the floor for questions. I know that was a lot, but how well did we understand that? Lakshmi, scale of 1 to 10. How much did you understand?
Yeah, John, actually I have few questions on this. Here in manager, we are implementing the claims enabled security, right? The manager service.
Yes.
But ideally it should be web, right? Yesterday you were telling that WIF should be running on top of the web, right? But why we are actually doing these claims enabled security in the manager?
So, okay, so let me see if I understand your question.
Yeah.
Why you're questioning? You're saying why isn't the web application doing security, right?
No, actually, web application should check for the tokens and all, right? Here, not actually manager access and all. So that should be separate service. I mean, claims enabled security should be the separate, and web should be separate. We are actually implementing that security, claims enabled security on the web.
So, so we are not. Let me see if I can. Let me see if I can frame your question. So your issue is that we have a website, and the website has WIF, right? Back to this guy.
Yeah. Yeah.
Okay, let me go back here. So the website is WIF protected.
Right.
Right. Okay, great. So the website is in charge of authenticating the user, or rather, better stated, is that the website is in charge of communicating back and forth to the STS to make sure that the user is authenticated, not authorized.
Yes, right.
Not authorized,
Right.
but authenticated,
Right.
right?
Yeah.
The manager is in charge of authentication, making sure that the call to that particular operation is authenticated according to what the operation does. The website doesn't know anything about the operation. The website knows to call the operation, but if we put security information inside the website, then the website would know far too much about that operation. The only thing that should know about the operation is the operation itself. And the only thing that should know about the authorization of the operation is a class that works with that operation. If we promoted it up to the website, that means the website would have far too much knowledge about each operation. That's number one. Number two is that that manager could be being called from any place, not necessarily the website. It could be being called from several websites, or it could be being called from another service. So then I would have to duplicate all of that authorization code all over the place instead of in one place. How's that?
Yeah, right. Yeah.
Does that make sense?
Yeah, yes, John, actually claim means it's authorization, or some claim means authorization, right? It contains the permission of the particular payroll data, which you are explaining about that, right?
Yes, yes.
Yeah, yes, okay.
But claims also have identity information in it. So claims will have your username, for example, and your user ID, for example. And what I do is I say that a claim can be an identity claim or an authorization claim. There's only a few identity claims, and the only claims that go back and forth in the cookies are the identity claims, not the authorization claims. And I do that because if I sent back and forth the authorization claims, then the cookies would be huge, and it would slow down the system dramatically. So we use the identity claim to go to the cache to hydrate the authorization claims.
Okay. So, okay. So here in web application we have different tabs, right? HR, payroll, and some compliance and different tabs, right? For each tab, we are actually creating separate claim.
No, no. So claims are outside of any application. So claims are based on, and you guys haven't seen this yet, but there's a security administration application, and through that security administration application, a customer can specify the security of their users through roles and permissions. From those roles and permissions, we we know what the claims look like. And there is not necessarily a claim for an application. There is a claim for an action. So
Okay.
three different applications could all execute the same action in some way. And the security system will understand actions, not applications.
Okay.
Now, maybe a person can get into the HR web, but they might not be able to do anything. So it depends on how the authorization is set up.
Okay. So security, suppose I have one security token, right? My security token might contain both authorization claims and authentication claims, right?
At different times, they will. So
Okay. Uh-huh.
here's the story, right? I want the browser's cookie to be very lightweight. So when the cookie will only contain the identification claims, and there will be
Oh,
4 or 5 identification claims. But the time it gets to the manager, the the security will be completely hydrated, and that it will not only have the 4 or 5 identification claims, it will have the potentially thousands of authorization claims. But that's not in the cookie. That doesn't go back and forth in the cookie.
mm.
Okay?
Yes, yes, John. Yeah, got it.
Lakshmi, you know why I'm very impressed right now, Lakshmi?
Why, John?
You
I,
challenged me, Lakshmi.
yes.
You
I will
challenged
challenge you
me.
in this.
In effect, this is what you said to me. This is exactly what
Okay.
you said in my terms. I know that you're much more
Okay.
respectful than this, but in my terms, you said to me, John, you're full of it. I don't believe you. You're wrong. And for, and for that, I appreciate it. Keep doing
Okay,
that,
thank you.
Lakshmi. Don't stop
Okay,
doing
John.
that. Okay? All
Okay,
right.
okay, then I call you daily then.
Okay. Hamat, you had a
Okay.
question.
Um, yeah.
Yeah, it was basically like when we say identity claims, you mentioned that like there was one attribute which was stating whether it falls under payroll group or not.
Right. So what I mean by identity claims is this. So the claims look the same. So we have the security utility, which is the data structure that holds the HSB claims identity, which is the data structure that holds the HSB claims list. And the HSB claims list is an numerable of HSP claim. That list will contain 2 types of claims. Now, I want to be clear about what I'm saying. It only contains a data structure called an HSP claim. And an HSP claim is very simple. Um, it has a name and a value. So some of those claims, when I say our identity claims, the name might be username and the value might be John. The name of the claim might be security, account ID, and the value might be 23. So I would consider these two claims to be of the type of identity. It will also have authorization claims where the name might be blank and the value might look something like this. And there might be another one, and another one, and another one. It is these claims that is in the security token. Only 4 or 5 of them, or 6 or 7 of them. And that makes the security token very small. And that's good because that makes the cookie small. And that's good because every request that goes back and forth must carry that cookie. And if that cookie is 20 bytes, it's much better than that cookie being 2 megabytes. So that's the difference of what an identity claim and an authorization claim is. I don't know if that answered your question or not, Hamad.
So when you say like the three URLs mentioned over here, like for example, you have given on top just no 5 to 6 lines above. So these are authorization claims that you discussed initially.
Yes, these claims in the cookie are authorization claims. Yes.
Yeah. So like when we read authorization claims, like all the claims should be read, right?
Yeah. These are authorization claims, and all the claims will be there. Yes.
Yeah. So like the basic authorization concept would be something like identifying which applications and like which branch or rather customer entity, identifying that part first, and then rest of the operation related authorization will be done through database. Would
Hamad,
that be
I'm
correct?
sorry. 1 second, Hamad. 1 second. Excuse me. I apologize for that, Hamad. Could you please ask the question again? Make your statement again.
Sure. So as per these claims, like we will be having multiple authorization claims which will be read, and those authorization claim will help us to identify the application, which application it has access, which branch, or rather which customer entity it is referring to. So you are doing that authorization first, and operation related authorization will be done through database or maybe the caching mechanism.
That's correct, Hamad. That's correct. One more second. I apologize again.
Okay, so it
Sorry.
is due. Sure.
Oh, I'm sorry. It's just that I get people in
No worries.
production that need me and blah 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 blah. Okay. Um, so so
Okay.
I want to make this one important point that by the time, what does the developer have to do, and why does the developer care? You know, I want you to know this because I want you to have a good understanding of what security is. However, the time it gets to the developer, all the developer really has to know is how to and when to run a statement like this. If our operations are protected, then they have to say who has the ability to execute this operation and who does not. The requirement will tell you that somebody that wants to get a list of payroll definitions needs to have some type of payroll data for that company and company entity. And it's important for the developer to have an understanding about this fluent interface and for these words, these methods to be meaningful. The claims behind this is really good to have an understanding of, but you don't need to use that information unless you were writing security software, which at some point you might be, and then it will become more important. Otherwise, for 99% of the development, it's abstracted into these statements. These statements are really important too, because think for a moment what we're saying. Has any permission within? If we have a tree of permissions, and you could have 32 permissions inside of payroll data, think of what that statement would look like if somebody has permission for this, or somebody has permission for that, or somebody has permission for this. I mean, this statement could be 72 lines of code. Instead, we're saying if anybody has permission within this parent of payroll and this company ID and this company entity ID, then let them in. So all of this stuff that we've been talking about boils down to, for the developer, those few lines of code. Everything else is abstracted. Which, by the way, is how we work with just about everything. I think when I interviewed everybody, I asked them, do you know WCF? Well, guess what? You don't have to, WCF, as you can imagine, it's extremely important to us because we are a service-oriented architecture in Microsoft shop. Well, the chances of you ever using your WCF knowledge is very little. Why? Because we abstract it. I asked everybody if they knew what in Hibernate is or an ORM is. Well, you use your ORM skills very little. Why? Because we abstract it. Service bus, we abstract it. WS Fed, WS Trust, SAML assertions, we abstract it. Why? Because we write 56% of our code is generated. Why? Because I don't want, wouldn't you agree with this, Hamad? If people are writing this code does not provide any business value at all to the company. It just doesn't.
Yeah, I agree. Because
You-
most of the code is actually plumbing code,
Yeah,
which
right. This is what's valuable to the company? This is valuable to the company. Writing code like this, the sum of the bill is, the values of all the line items of that bill. That's valuable. That's the code that's valuable. Fortunately for us, that's the simplest, smallest code you'll ever write. It's all the other crap that you don't have to write that gets in the way of business value. And by the way, if you don't have to write this code, you don't have to test that code. And if you don't have to test that code, you can might write more of this code. And the more code like this you write, the more applications we produce. And the better it is because the smaller the code base. That's why we have software that's 3.5 million lines or 3.2 million lines of code. And, we only have uh, just a few, relatively speaking, we have a small shop compared to how much software and the complexity of that software. We have a very small shop. And that's because we abstract most of this kind of code. The developer simply has to understand how to use the interface into the authorizations. Another good example of that, let me just go to an access service for a moment. Payroll period access. So another good example of that is, here we have entities, and an entity roughly reflects a table in a database. So with nhibernate, there are several ways to define this, but with nhibernate, you would have to know how to write this type of code. That's the definition for the payroll period. Oh my goodness. Oh my goodness. Why would I want to write that? And look how much of it there is. Every single entity needs its own HBM. Now, there are different ways you could potentially do it, not in XML, but you get the point that I don't want people writing that code. And oh yeah, by the way, what if I want to get a very common thing to do in any database would be able to get a single row from a database with its ID. Well, I don't want you writing that code. There's nothing special about what that code does. So instead, we generate DAOs. Let me just show you real quick. I don't want to turn this into a framework session, but if I were to look at, payroll period, and I were to look at a query, I can see that we have, oh, that's the interface, sorry. A query down here. We can see that there's all kinds of queries that have been written for us, so that if we want to get a row from a database, we just have to say, hey, payroll period DAO dot get by ID 42, and then you have it. It's just, this doesn't add any value. So that's kind of our one of our philosophies that we have is I only want you guys writing code that's meaningful to the business, and that's less than half of it. Okay, I've been talking for a long time. Anything else? Lakshmi, what do you think? You want to challenge me again?
Yeah. No, John, actually, I have one more question here. Huh?
Yeah.
Yeah, actually, 1 minute, I forgot that question.
It's okay.
So in the web application, we have different tabs, right? I am authorized to view few of them. So I need to authorize extra tab, one more. Where do we write code for that?
Okay, wait a minute. Let me get back there. Payroll period manager. Authorize. Okay. So a little bit more slowly, Lakshmi. Ask your question again.
Yeah, actually, I have authorized to view few of the tabs in the web application, in the web OSC web. I need extra authorization for other tab. Where do we write code for that authorization of the particular other tab? Where do we write code?
So every manager, or every operation in a claims enabled system, in a claims enabled service, will have authorizations. Now, when you said, did you say the word tab?
Okay, tab.
You mean like a tab
HR pair.
on in an application, right?
Yep.
Okay. Well, when you think about it, how do we determine if that tab is there in the first place? Through a manager call, right? Because a
Yep.
manager call might say, "Give me the tabs," and
Okay.
and that operation will first say, "Is this person authorized for tabs?" And if he's authorized, then we go get tabs. Now, we might have got 10 tabs, but then there's another concept in security called redaction. So let me explain what redaction is. Redaction is this. John is authorized to see tabs. Okay, cool, great. I'm authorized to see tabs. So go get the tabs from the database. Great. Now, John's authorized to see tabs, so we go get the tabs from the database, but then we have another question to ask. I have 10 tabs. Can John see all of them? So I asked the security system, can John see all of them? And the security system says John is only authorized to see 8 of those 10 tabs. So I have to redact 2 tabs. Redaction is the process by which we filter data based on authorization information. Now, one could argue, one could say, geez, why not just do this? Select star from, I'll just use the word tabs, where, I don't know, some authorization, authorized ID in 2, 4, 6, 5, and 8, whatever. And I let the database filter these tabs. Well, it's just not that simple, Our databases are carefully designed. It does not necessarily follow functionality. Neither does our code. Let me make that statement again. Our code does not necessarily follow the functionality of the requirements. It should never do that. And that's the way 99% of the world will write code. 99.99% of the code will look at the requirement, break it down in terms of functionality, and then write code that satisfies that functionality. We never do that. Oh my goodness, we never do that. And now you're saying, John, you're crazy. You have to do that. Well, no, I don't. There's only one thing there's the code we write satisfies volatility. We don't write our code to satisfy functionality. So that's probably just got you a little crazy at this point. That's a subject of another day. But getting back to your question, sorry, I digressed. Getting back to your question is the manager, the UI will call a manager, right? And it might say, one question is, give me the tabs that I can display. The manager will first say, hey, is this person authorized to see any tabs for this particular company? If not, you get an authorization exception. But if you can, great, we go get the tabs from the database. Now we have the next question to ask. We have 10 tabs. We might have to redact that information. A perfect example of that is, payroll documents. Okay, so we say, does this person have the capability to view payroll documents? So the authorization code says yes, they do. So we go get the documents. Then we might have to examine the document. There might be a document in there from the CEO or the CFO, Chief Financial Officer, or whatever they may be, stating that no one other than the CFO can view. So even though that person has authorization to payroll documents, there could be further information in that payroll document that somebody has stated nobody else can view. So if that's the case, of the, let's say, 30 documents that were retrieved from the database, we must redact one. Who knows about that? Who should know about that? The database? No way. The database should not be promoting business roles. Can you imagine if I allowed the database to understand these values, what kind of database code we would have to write? That would be crazy code. Instead, no, we have a nice object-oriented system that's abstracted away, and then the only thing the person has to do is learn this fluent interface. So I hope that started to approach your question, and I'm not sure if it did. So tell me if it did or did not.
John, actually here what I'm asking now, in manager, we are actually creating claims identity in the manager level, right? What do we need to do any security level code in the web? I'm asking in the web, OAC web.
So the security, the claims is already hydrated for you by the time you get there. The developer doesn't have to do anything to the tokens or extract the information. The developer will have this HSP claims identity already available to you. Was that your question? Was that your question?
Yeah, no, I'm actually asking, no.
Right.
Here in manager, we are actually doing claim identity tokens, and we are security level functionality. We are implementing the manager.
No, you only have to worry about, in the manager, you only have to worry about determining this very specific information in the manager.
Okay.
In the operation.
John?
Yes.
Okay.
Ashok, go ahead.
Mute. Yeah. John, I believe what she is asking is like from the web application, we are already doing a claims token, and this again we are repeating again in the manager. So the internal functionality is something like maybe she is looking for how the claims is associated with the thread or the processing thread.
Okay, so if that's the question, let me see if I can answer it.
Yeah.
So HR Web has the token. Okay, so let's start there. HR.web contains a token. HR.web calls
John,
a manager. Yes.
sorry to interrupt you, but today I have to leave. It's my kid's birthday today, so I have to, leave this call.
Happy birthday to your kid. And
Thank you so much.
you can you can watch the rest of the video. I'm going to clear it up in maybe 10 or 15 minutes, so you can just
Thank you
watch the
so much.
video and get it. Okay. Happy birthday. Eat some birthday cake. Do you guys do birthday cake in India?
Yes,
Okay.
yes.
Happy birthday. Great.
No,
Take care.
thank you. Thank you.
Okay. Bye.
Do you need Ken?
No, I don't think so.
No. Okay.
Okay.
Okay, then. Thank you so much.
Thanks. So
I'll talk to you later.
great. Take care. Lakshmi. So HR contains a token. Now the
Yeah.
HR web contains a token. Now HR web calls a manager. Okay.
Okay.
I don't know how well you know WCF, but I will talk about it in terms of WCF. So when this call is made, we extract from the token something called something called a bootstrap token. We then place that bootstrap token out of band to the message. So what I mean by out of band is this. We might have a WCF call that looks like this. Get dog ID 24, whatever. That might be our operation. Well, nowhere in here do you see get dog 24 token. I would vigorously argue that that's a ridiculous call. Why? It doesn't have anything to do with token and burdens the developer with things that they shouldn't have to worry about. So instead, what we do is we get a hold of this message that's sent to WCF, and this ends up being a SOAP call, and we place the bootstrap token inside that message. Unbeknownst to the user, to the developer, that bootstrap message goes inside the SOAP message. Now, on the manager side, code will intercept the WCF message. It will then read the out of band data. It will then use that bootstrap token to create the HSP claims identity. It will then ask another service for the claims. That other service will go to the cache and retrieve claims. If not there, it will go to the database to get the claims. Returning a fully qualified, fully hydrated security token containing the identity. The identity holds the claim list. All of this takes place before the operation is called. I should say the service implementation is called. Now the service implementation is called, and the operation of the service is called. The generated code will call the authorizer class for that particular operation. The authorizer class will call on the Fluent interface to determine if the user can access the operation. Sometimes we call on a redactor class to redact, filter data that the user should not see. So to look at that a little bit more closely, we see that the references, authorization, generated, implementation, payroll period manager. Here is the WCF service. Here's where we started this discussion. Here is the WCF service. The and it's generated code. Inside that generated code is a generated method. That generated method will do some things. One of those things, it will call this get payroll period definition list authorizer here. That's where some hand code is written so that the developer will determine from the HSP claims identity, which has already been fully hydrated, what the user can do. If this returns false, then the generated code will throw a CPI authorization exception, and the user code will not be allowed to continue. But if the authorization returns yes, then the operation code, the operation class, which is this class, can be called. And that is the partial class. The handwritten class is this guy. That can be called. And by the time I get here, this operation doesn't have to worry about authorization. All of that work. And I hope you can see that there is a lot of work that gets a person from this URL requesting some information all the way down to the operation that you call just to authorize. And you don't have to do any of that except for writing the authorization piece, the small authorization piece that says you can allow this person in, and then the actual operation itself. That was a mouthful. How was that?
Yes, sure. Actually, I got it. Okay. Whenever I have one more question here. Whenever I do some security level operations, I need to disturb only manager, no web, right?
That's correct.
Yeah, I got it now.
Great. Okay, I'm going to end it there. That was actually 90 minutes, probably longer than I wanted, but I'm going to end it there. And unless there's anything else, I'll talk to you guys next week.
Yeah, sure. Thank you, John.
Thanks.
Thank you, John.
Thanks.